Okay, in this video, I'm going to do an ideal gas law problem. And I've got the problem written here. It's the pressure of a 16-liter container of gas is 2.5 atmospheres at a temperature of 320 kelvins. How many moles are there? Okay, so the first thing I want to do is to list the variables and their values. So let's start with pressure. And according to our problem, is 2.5 atmospheres. It's helpful if you know the units. It's easier to match it up with the variables if you do. Since I know that this is the ideal gas law, I'm just going to list them in order here. So P, V, and then I'm going to do N, and then R, and then T. Okay, so the volume it says is 16 liters, and N is moles, that's what we're looking for. And the temperature is 320 kelvins. All right, so the only other value we need is R, and R is the ideal gas law constant, and we can always substitute the number 0.0821 liters times atmospheres over moles kelvins. Okay, the units are kind of crazy, but that's what allows us to cancel the units in the rest of the problem. All right, the next thing I want to do is to write the equation, PV equals nRT. And then, so that I don't have to shuffle a lot of numbers around and take a chance on the making a mistake on the calculator, I'm going to solve for n. So here's n, which means I need to divide by everything else on this side. That's going to be r and t. So r cancels, t cancels, now n's by itself. And if I divide by rt on the right, I have to divide by rt on the left. So the equation we're going to use is n is equal to pv over rt. All right, so now it's just a matter of plugging the numbers in. So pressure is 2.5 atmospheres. And then we're going to multiply that times volume, 16 liters. And then we'll divide that by R. 1 liters, atmospheres. I know you'll get tired of writing this, but it's what makes this work. And we're going to multiply that times 320 kelvins. All right, so the first thing I'm going to do is make sure that my units cancel. And, excuse me, before I look to see if the units cancel, I want to make sure you understand that when liters, atmospheres over moles, kelvins is in the denominator, it's like multiplying times moles, kelvins over liters, atmospheres. So, for example, if I rewrite this, 2.5 atmospheres times 16 liters divided by 0.0821. Instead of putting the units right here, I'm going to tag them onto the end. And I'm going to flip or invert the fraction for the units because I'm multiplying them now instead of dividing. And that's a good way to deal with it. So just tack the units onto the end of the problem and invert the equation. Okay, and then I also want to multiply by 320 kelvins. Okay, so now we can do the canceling. And we've got atmospheres on the bottom, atmospheres on the top. Kelvins on the bottom, kelvins on the top, and liters on the bottom, liters on the top. So what we have left is moles, which is a good thing because N is in moles. So then I'm going to plug that into my calculator. It's 2.5 times 16. And then I'm going to divide that by the product of 0.0821 times 320. And the answer is 1.5 moles. All right, so I started by listing my variables. I wrote the original equation, then I rearranged it for n, and then I plugged in the values for each of the units, or excuse me, each of the variables. And then to make sure the units cancel, I took liters, atmospheres over moles, kelvins, and tacked it onto the end of the problem as moles, kelvins over liters, atmospheres. Everything canceled. Plugged it into my calculator, and it ended up with 2 significant figures because that's what I had in all of my problem. There you go.